Good afternoon and welcome to RDA's Tech Talk. Today's topic will be Azure Table Storage and DocumentDB, NoSQL in the cloud. RDA's Tech Talk series is designed to be a 30-minute technical presentation for the benefit of our customers centered around a current topic. And we will have about 25 minutes of presentation, including a demo, and then address some questions at the end. So you'll be able to send questions at any time using the GoToWebinar Q&A interface. A few logistics before we get started. First, as a part of our fall relaunch, we are giving away 2 Papa John's gift certificates at each of our Tech Talks. So we will pick 2 lucky attendees and announce them at the end of our session. And secondly, we'd love for you to join RDA's Tech Talk LinkedIn group, and we will be providing you access to speakers for pre- and post-session questions, as well as sharing materials with you. And we will also share a link for this at the end of the session. All right, so let's get started. I would like to introduce our speaker for today, Jason Petrin. And Jason is a senior software engineer and a 6-year veteran consultant with RDA. He works as a custom applications development engineer, specializing in cloud development and enterprise integration. So with that, Jason, thanks for joining us today. You are the presenter, so the floor is yours whenever you're ready.
Thank you, Patty, and welcome everybody. Thank you for taking some time out of your lunch hour to listen to what I have to say in between eating. So as Patty was saying, our topic today is NoSQL in the cloud, specifically Azure Table Storage and Azure DocumentDB. So just a quick rundown of our agenda today, and we have a lot to go over in 25 minutes, plus we have a demo so and Q&A, so we'll try to get through this fairly quickly. But I'm going to go over first what is, to level set everybody on what NoSQL is. We're going to talk about what is NoSQL, put a definition on it, and then we'll talk about the main differences or the main categories of NoSQL. Then we're going to dive into specifically the Azure versions of NoSQL, which are Table Storage and DocumentDB, and we'll follow that up with a quick demo and a Q&A session. So to get us started, you probably have heard this the expression NoSQL. Right, and I'm not a big fan of the term. I like the term non-relational database, because when you say NoSQL, a lot of database administrators, DBAs, will hear that and think that's hostile towards them, and that's not what we're trying to be. We're trying to give them more tools, not take their tools away. So we're talking about non-relational data store, and what that means is, in our traditional relational database management systems that we have today, like SQL Server and MySQL and Oracle, everything is compartmentalized into tables, and those tables are related to each other, and we have normalization, and that's how we have to store our data. It's very tightly coupled to the schema. We're all beholden to the schema, and if there's changes to the schema, a lot of times there's some cascading changes that we have to make inside of our code. Also, because the way we store data is not how we use data in the applications most times. We've invented this entire basically cottage industry of tool components called ORMs, or object relational mappings, right? Like Entity Framework and Hibernate and things of that nature. That basically all they're there for is a middleman to translate relational data into non-relational data like we use it in our applications and back, right? So somebody came along, or in this case a lot of people came along and said, why are we doing that? Why don't we have a data store that we can just store these things as non-relational, and then we don't have to go through this whole middleman and translation, and things are better suited for use in our applications. So the main types of NoSQL that we have are key value stores, document databases, graph stores, and wide column stores, and we're going to talk about each one of those. So for key value databases, and this is specifically, and you'll see this later, this is Azure Table Storage. What everything is stored as a key value, right? So if you think about a big dictionary, as a database where you have words and their definitions, right? That's what key value is. It's very simplistic. It's the most simple NoSQL storage that we have. It's really great for flat constructs. Rewrites on it are extremely quick because there's no complexity, right? We've stripped all the complexity out, and we're just basically saying, okay, we have customers, and customers have names and emails and phone numbers, and it's not really spidering out. It's just one-to-one relationships. The problem that this has is when you need to get into deeper relationships, it doesn't directly support those as well, which is why the next type was developed, which is our document databases. So document databases, and those that are familiar with JSON or even XML will recognize this formatting, right? So we have these nested data objects. So in this case, this is a JSON example where we have person, which is made up of a first name and a last name, which is simple one-to-one, and also some complex types like address and phone number. We're able to nest as many complex types as we want to with a document database, which is the one drawback to, or the main drawback to key value pairs was it wasn't able to model out complex types like we normally use in applications, right? So if you think about document databases as a place to store POCO objects or plain old C# objects or JSON, XML, it's hierarchical data stored in the cloud. The next one we have is the graph databases. These are a great fit for if you can think about your social networking websites or any kind of social networking. Basically, we've flipped the script on the database, if you think about it, where data is important, but in this case, it's not the most important. The most important thing is the relationship between the data. So it's not necessarily your first name and last name that make up you as a person. It's who do you know? Who are your relationships, right? And also between other kinds of data types as well. It's not necessarily, it's the computer, like if you store a computer object in this database, it's not the computer that's important, it's what's that computer connected to, right? So this lends itself to queries where we're doing wide, basically casting a wide net to pull in a bunch of child objects based on relationships, right? So if you think about if anybody's used like LinkedIn, the first thing that happens when you log in with LinkedIn is it's like, hey, here's 50 people that you may know because they worked with somebody you worked with, or they worked at an employer that you worked at around the same time period. So maybe your paths have crossed. So this leads itself to those types of queries. Big data, right? So wide column stores. So a good example of this one is Cassandra, right? And if we think about big data or Hadoop, so Hadoop is a way to run queries against big data, but where do we store the big data, right? Cassandra is a good example of I want to dump a lot of unrelated data into a data store that I'm going to do regular work with. It's supporting my application, but I also want to be able to hook Hadoop up to it and run analytics on it in the background. So if you have any kind of data that is just like IIS logs, that's the contrived generic example that everybody uses for big data. But if you have your IIS logs or your if you're logging, you want to track habits of people that visit your website, you can do Hadoop against that data and get the results of those queries to try to gauge what your high traffic points and what should the priority of your website be as far as doing revamps or enhancements. And you're also using this data to support your website as well, i.e. parts of this data are actually exposed on your website so you can go look at it. That's what wide column stores are for. So specifically what we're going to talk about today though is Microsoft Azure, and they've dipped their toe in the water they've weighed in, so to speak, into the whole NoSQL arena. And they've been in that spot for a long time with table storage because that came out when it was originally Windows Azure. But when Azure first came on the scene, one of the very first services they offered was table storage, right? So they've been in this market for a while, but then they've weighed in a little bit more heavily over the last couple of weeks with DocumentDB, which is literally only about 2 weeks old, and we'll talk about that as well. So with Azure Table Storage, if you recognize this graphic from what we were just talking about a minute ago, with our key value pairs, this is the same graphic because that's what Azure Table Storage is. This is a key value pair data store. So what we could do with this, and this is great for keeping basic like session data, anything that needed to be decoupled from the website or from the server, you could put in here, and it's very, very cheap compared to doing a full-blown SQL server or an Azure SQL instance, right? So that's initially what it was for. It was a way to move your websites into the cloud, move your applications into the cloud, and still have a place to have your session data that's not tied to like a sticky session or to your server, because that's a whole other topic, but we can talk about why that's bad, why you don't want to do that in the cloud. So that's originally what this was for, but it was also a good place to put simple data. So if your website didn't need the full-blown SQL Server instance with all the relationships that are required with that, this is a good place to store that kind of data. Like configuration data, that sort of thing. So some features of table storage is it's cloud native platform, or I'm sorry, yeah, platform as a service. And that's a fancy way of saying that this is fully supported on the back end by the Azure team. There's really not a whole lot to set up other than telling them that you want it. And they take care of all your backups, all your restores, all the hardware issues. There's nothing much to maintain on your side. It's very minimal administration, right? So that's what's really cool about the platform services. All their platform services, or the majority of them, are very durable. Everything's in triplicate. So you have the instance that you actually call, and then it's also being duplicated twice over in the background, so then you have 3 copies. So if the active node goes down, it gets replaced by one of the passive nodes, and then there's a third node stood up in the background, and it syncs up with the other 2. So that way you get the 99.9% uptime, right, without having to purchase multiple instances or anything like that. It's very scalable. You can get up to 200 terabytes per account, and 200 terabytes may or may not seem like a lot, but when you're only talking about textual data and it's all key value, it's a lot of data. Cheap. It's extremely affordable, especially compared to SQL Server or even DocumentDB. It's fully accessible with REST API, and there's also a number of SDKs that can talk to it natively, .NET, Java, Python, Ruby. I think there's a couple others. I think Node.js is in there as well. But it doesn't really matter what you're coding in because they have REST API, so you can always talk to it with the REST API. And also new features, typically, this is with all the Azure things, they'll show up on the REST API before they actually show up in the SDK. So something to keep in mind there. If you don't know REST, you probably want to look into it. So here's some strengths and weaknesses. One of the strengths, like we said, was that it was a platform as a service, right? So that means all this stuff is done for you. It's managed by the Azure team. So that's why there's no dedicated server, right? You don't have to have an on-prem server. There's no server in the cloud that you have to stand up or anything like that or maintain. They take care of it for you. The size automatically scales. You put more things in your table account and it gets bigger, right? Unless you ever exceed that, was a 300 terabyte or 200 terabyte limit, you don't have to worry about scalability, right? So it's something else that they're taking on their shoulders that you don't have to deal with. Triple redundancy, like we talked about. You're accessible via multiple means, SDK, REST API, all this fun stuff. Some weaknesses, because it is in the cloud, you have to have an internet connection to talk to it. That's just part and parcel with being in the cloud. It's just one of those things. It's a simple key value pair store, so you're limited to the abilities that you have for key value pairs. So just the constructs that you can make with that is kind of your limit. What I have seen people do is actually store JSON data as the value in a key value pair and just pull it out and use it. The problem with that is searchability, but that's, may not be that much of a concern to you. It just depends on how you're trying to structure your data. If cost is a concern, that might be an available option to you because this is very cheap. And it's also Azure native. So that's a strength and a weakness, right? The strength is if you're developing on the Azure stack already, that's awesome. That's a strength. It's here. If you're not developing on the Azure platform, let's say you're using another cloud provider or you're doing everything else on-prem, that may be a detriment, right? So it just really depends on your architecture, on whether that's a strength or weakness. Again, no database schema. With all the NoSQL stuff, we get that inherently, where if we want to add a field or take a field out of an object, we just do it. It doesn't. We don't have to go and run a change script to change the database and update our ORM and then refactor all of our code. All we have to do is remove the field and refactor our code, and we're done. So the next thing we're going to talk about is DocumentDB. So DocumentDB, based on its name, is a document database store. I know the Azure team's really good with the names. Table storage is confusing because it sounds like a SQL server, and then DocumentDB is very clear but very simple. There's no wow factor here. But it is a document database, which is awesome. And so we can store more complex types in it. Also, searchability is fully supported. So a couple of things that we want to talk about with DocumentDB. Again, just like table storage, it's a platform as a service, which means all this management is done for you. All you have to do is basically allocate the space, stand it up. There's a couple of switches that you get on this one that you don't get on Azure Storage, Table Storage, which we'll talk about, like the scalability and the configurable consistency, which we'll talk about in depth in just a second. So this is you're actually able to run transact SQL queries against this database and pull out things as cool as like give me all the users that have the first name Jason, right? Or you can say give me all of the users that have a dependent name Jason, right? So you can get a lot more creative with your queries here than you can with a simple key value pair data store, which is basically give me row ID XYZ. Right? Whereas this, we can actually write robust SQL queries. We can also write our queries in LINQ if you would prefer. It does support blob attachments, but the attachments, I'll have to check on this. I don't know if they go against your space allocation in DocumentDB or if they go against your space allocation on your blob storage. So if they go against your space allocation in DocumentDB, you're probably better served by just putting a link to your blob that's actually in blob storage. But if they don't, if they do that for you, then this is all kinds of awesome. So what that means is, like, if I have a personnel document and I want to attach a picture to it, it supports that, so it all comes back together if I want it to. Also stored procedures. This is not transact SQL store procedures. These are JavaScript that gets run, but you can create your own store procedures, save them into your DocumentDB, and then have those run, or you can call those from your API. And it can do some data manipulation, and all that happens on the server side, so it's not dealing with your client resources. So pretty cool thing to know there. Triggers are also supported as well, so you can write your own triggers. Again, accessible via the REST API. There's also some SDKs, but there's only a couple out because it's brand new. And like I said, REST API is always like the first supported. So if you go REST API, you never really have to worry about will my ability to call the system work? So the SDKs that are out right now are .NET, Node.js, and Python. Oops. So we're going to talk about, if you notice the bullet point on the previous slide, about configurable consistency. So the first thing I want to talk about is, let's level set our knowledge of consistency first, right? So here's the CAP theorem. So what the CAP theorem stands is each of the letters stand for something: consistency, availability, and partition tolerance, right? The CAP theorem, like many of these triad theorems here, if you can see by the Venn diagram, is you can take any two, right? But you can't have all three. There's no such system in the world that gives you consistency, availability, and partition tolerance all at the same time, right? So the traditional RDBMSs that we're used to, SQL Server, MySQL, Oracle, they have high consistency and high availability, right? That's the way they're built. But they don't handle a partition going down particularly well, right? But they give you, what I write is what I see. So if I make a change to the database and then right after that change I do a read, I will see what I just wrote, right? That's guaranteed. So the next type of consistency is high consistency and high partition tolerance, and those are things like Voldemort, Cassandra, and CouchDB. These are all NoSQL instances, but what they give you is partition tolerance, which is something we don't normally get, and then these also give you high consistency. So what they do is they immediately write to the partition. If a partition goes down, you're still okay. And you can get your data is constant. So there's no, our third type, which is the one that a lot of people know, which is eventual consistency. There is no concept of that. I mean, the data doesn't lag along; it's always there, but we take care of the partition. The problem is that we don't guarantee that that you can get to the data, right? So that's one school of thought. And the last school of thought is eventual consistency, which seems to be the most prevalent outside of relational databases in Mongo, which is probably one of the largest, if not the largest, NoSQL provider right now. It's one of my favorites. It's a DocumentDB as well. But it has high availability and high partition tolerance, but notice we leave the consistency off, when that means that we're implementing what we call eventual consistency. And eventual consistency means that when we make a write to the database, we don't expect that data to be immediately available, right? So it is possible for us to write, change your name, and then do an immediate read off the database, and your name still come back as the old name, right? But eventually it will be consistent. Right, so that's just kind of the price you have to pay, and you know that what you're not going to do is, while I'm in my session, I don't want to make a write and then immediately read back. I probably want to use the data that I already have in memory instead of going back. But there's no partition, so if a partition goes down, everything goes down, right? Because they all have to be in sync. And then we have eventual consistency, which is the data is eventually consistent. It's not really possible to read old data, or I'm sorry, it is possible. It is possible to do a read and get old data if the write is recent, right? So those are two of your choices. The other two are bounded staleness and session. These are new. These were new to me when I first saw this a couple weeks ago. We'll start with session because that's the default that DocumentDB ships with. When you spin up a new DocumentDB instance, it defaults to session, and you can change it from there. But the session, which I think is actually probably my favorite consistency level right now, which is basically means that you have strong consistency within your session, but eventual consistency outside of your session. So that's a fancy way to say that in my session, if I create a document and put it in DocumentDB, it is immediately available for me. If I make a change to the document, it is immediately available for me, but it's eventually available for anybody that's logged into a different session. So if that makes sense. And then bonded staleness, this is the one that's a little bit weird. It's got very low latency writes and high latency reads. What that means is that it's eventually consistent, but to the extreme, right? So if I make a write, it immediately takes that write. So this is for high volume, right? So if I'm pumping in thousands of documents in a short period of time, those all get into the database. All those writes will be accepted into the database very quickly, but by the time I can read that data back out, there's going to be a strong delay. So this is to deal with high volume of writes versus high volume and low volume of reads. That's more of a niche setting. So Azure DocumentDB, strengths and weaknesses. A lot of these are the same strengths that we get with table storage. The main difference here is the fact that it is a document database, and it is it supports stored procs and triggers and SQL Server queries and all that fun stuff. Weaknesses is it costs more than table storage. It also the same weaknesses as table storage as well. It requires an internet connection. You're not tied to a schema, which means people can put user documents in your address collection. I mean, people can mix and match it. Developers, if they're not being managed, and then it's also is Azure native. So great if you're on Azure, might be a problem if you're not. So here's some important links about what we talked about today. We have the table storage website, the DocumentDB website, also a couple of the other ones that we have. So here's examples of the other three types. Well, we have MongoDB, which is also a DocumentDB, Cassandra, which is a wide column store, sorry, and Neo4j, which is a graph. Which those are a little bit to get your head wrapped around if you haven't used one. So that's an interesting read in and of itself. I highly recommend it. And then also a fellow RDA member wrote a NuGet project called the ASP.NET Identity 2.0 Azure Table Storage, and we're going to see this in our demo. And sorry, I meant to mute my phone. But a fellow RDA named Dave Melendez wrote this identity store. So anybody that's used, pulled out, created an MVC application and I will talk while I go over to that. If anybody's used an MVC website using Visual Studio and you use the default security that's built into it, right? The whole identity framework that's built into it. It uses SQL Server on the back end. So what Dave did was he refactored it in such a way that it uses table storage instead, right? So if you're wanting to go to the cloud and you don't want to spend the money on SQL Server just to be able to support your identity framework, this is a NuGet project you can use to pull down. There's like 2 changes you have to make in your code and it works. And your dependency on SQL Server is gone, which is awesome. So I highly recommend it. So the demo we're going to do, we're doing some charity work for Aparo, specifically with their Hope project. And what their Hope project does is it helps needy families during the holidays. We're allocating coats and food and like the gift trees. If you guys have seen gift trees around your town, they run a database to try to connect what we call sponsors, which are donors, to applicants, which are people in need. So we're going to show that demo real quick. And all of this is back-ended with document database, and it's and then our identity framework that we're using from the NuGet project that Dave wrote. So we're back-ended with table storage as well. So we'll log in here real quick. So if we go to our user administration, all of this is, I don't really want to change myself from being an admin, but I can administer my roles from here, and this is all being stored in table storage. I'm using the emulator for that, so this is local to mine. So if I actually go to the preview page that we have out in Azure, it'll have a lot more users because the other developers are in here as well. But this is running locally, so it's running against the emulator, so this is just emulating table storage. But then if we go and look at, let's say, sponsors, and we search for sponsors, that's actually going to DocumentDB and pulling all the sponsors back and putting them in our results panel, and then we can deep dive into here and actually make changes and save changes back to the database. So very performant, very quick, very easy to develop. Didn't have to write any stored procedures, didn't have to mess with Entity Framework, and it's all cloud native. So let me go back to my slide deck. There. And I think we may have some time for some questions. I don't know, I ran over a little bit, and I apologize for that. But Patty, could you open the floor to questions?
Yep, so we are a little short on time, so I'm just going to address the one question that came in. And if there are others, we would offer that you guys could use the LinkedIn group, and I am just going to send that link out in the chat right now so that you guys would have that. All right.
It's on the screen. I left it on that screen as well, too.
Yep. And so in terms of the one question that we do have, what is the cost difference between the Azure Table Storage and the DocumentDB?
Okay, yeah, that's a good question. So table storage is extremely cheap. Currently, and these things change a lot, and they can also change based on your enterprise agreement if you have one with Microsoft, so you might be able to get a discount through that. But their standard, or their MSRP, for table storage is $7 for every 100 gig, and that's how they scale. It's not about transactions or anything else. It's just about how much space do you take up. So for every 100 gigabytes of data, it's $7, right? So that can, and it's not sold in increments of 100 gigabytes either. So it's just, it scales off of that. And then for DocumentDB, it's right now it's in the preview mode, so it's $22.50 a month per compute unit. And once it come out of preview mode, I think it's going to be around 45 a month per compute unit. And what you get for the compute unit is it's storage plus like or volume capacity, I guess is the best way to put it. You get 2,000 reads per second, 500 writes per second, 1,000 queries per second, and 20 space for 20 stored procedures, and 10 gigabytes of actual disk space, and that's all on solid state drives, not platter drives. So everything's very quick, and that scales up. So if you want to add another CU, you just go to your portal and say allocate another CU, and that's it. It's done.
Great.
Any other questions?
Nope, I think that's going to be all that we have time for. I will thank you for a great presentation and hope that everybody took away something new. We'd like to extend congratulations for today's Papa John's gift card winners. So that would be Norman Seamus and Jim Key, and I hope that I didn't mess up those names too badly. So I will be following up with each of you to provide you the information. So congratulations. And thanks to everybody who did join us today. Our next presentation is Wednesday, September 23rd, September 24th at noon, where our topic is going to be SQL 2014 and Azure integration features. So thank you and have a great rest of the day, and we look forward to you joining us next time.